Hey guys, welcome to section 5.3 where we're going to be graphing square root functions. So first we're going to get to know the parent square root function, which is f of x equals the positive square root of x. So just so you know, when we are given an expression that already has a radical in it, it's asking for just the positive square root. And you'll see why in a second. Okay. So we're going to fill in this table of values and plot the points and then draw a curve through to see what this graph looks like. So my input value x of 0 means I'm finding the what happened? I'm finding the square root of 0, which obviously is just 0. So that's the point 0, 0, which I'll plot over here. Then when I'm looking for the positive square root of 1, I get 1, so that's the point 1, 1. And then the positive square root of 4, I get 2, so that's the point 4, 2. And the positive square root of 9, I get 3, which is the point 9, 3. So when I draw this graph, 0, 0 is known as our endpoint, and it goes on forever up and to the right. So it should be a smooth curve up and to the right. Now, so my endpoint's at 0, 0. If I would have also allowed for negative square roots, let me just show you what that would have looked like. I would have also had the point 1, negative 1, 4, negative 2, and 9, negative 3, which would have been this part of the graph. Do you notice that that's a sideways parabola? And that's because square root is the inverse of x squared. So it should make sense that it looks like a parabola reflected over the line y equals x. But this parabola as is not a function because it does not pass the vertical line test. So to be able to be a function, that is why up at the beginning of these notes I said this just means the positive square root. So I'm going to erase all that other stuff. So only my graph that's in the first quadrant is our parent square root function. So something very important about this function is that it does have an endpoint at 0, 0. And then, so because of that, the domain is all x values greater than or equal to 0. So we can just write it like this. And all the y values are also greater than or equal to 0. Because obviously I can only take the square root of positive numbers or 0, and then because I'm asking for the positive square root, my outputs are also going to be greater than or equal to 0. So now that we know what the parent graph looks like, let's see how we can graph it. So graphing square root functions, this is our learning target for this lesson. I can sketch transformed graphs of the parent square root function, f of x equals the positive square root of x. Remember that we have transformed functions before, and we use the parameters a, h, and k as follows. So if I have g of x, it could be equal to a times f of x minus h plus k, or g of x would equal f of 1 over a times x minus h plus k. Remember that h is right or left, and we always have to think the opposite. K is up or down, and we just take it as it is. So if it's plus, we're moving up. If it's minus, we're moving down. But A is a stretch or compression, or shrink. I guess we use shrink more often, so I'll say that. Also, if negative, it can be a reflection as well. So let's remember those things, but it matters where A occurs, whether it's a vertical stretch or a horizontal stretch or shrink or reflection. So remember when A is on the outside, like in A times F of, that's a vertical. When A is on the inside, remember we always have to flip it, and that's a horizontal. So we always think reciprocal. And remember our H, we always think opposite. So I always say anything happen to the X's, anything that's horizontal is complicated. Well, we can apply that to any parent function. So when we apply it to f of x equals the positive square root of x, it looks like these two things we have down here. So given that, let's try example 1. Given each transform function of f of x equals the positive square root of x, identify the transformations that have been applied and the endpoint of the graph. So obviously, if we're going to move this graph, the endpoint would follow. Because it's starting at 0, 0, basically our endpoint is always just going to be hk. Just like when we transform parabolas, the vertex is always hk. So let's look at letter A. G of x equals x plus 1 minus 5. So because this is x plus 1, our h value is actually negative 1. Remember, always think opposite. And then minus 5 at the end is negative 5. So what we're doing here is we are going left 1 and down 5. So our endpoint, which I just write EP for endpoint, is negative 1, negative 5. Letter B, g of x equals negative square root of x plus 6. This negative out front is our a value, and it's a vertical reflection. So what that means is this is a reflection over the x-axis. So I just want to sketch that. If we have our parent graph right here in the first quadrant, if we're reflecting it over the x-axis, it will come down here and be this graph right down here. So that will move to the fourth quadrant. All right, reflect over the x-axis, and that plus 6 there is just up 6. That's your k value. So the reflection does not move your endpoint, but the up 6 does. So your endpoint is at 0, 6. So it'd be like up here and now coming down like that. All right, letter C. I have 3 times the positive square root of x plus 5 minus 4. That 3 is our a value on the outside. That's a vertical stretch by 3. Then I have x plus 5, which means our h value is negative 5. So that's left 5. Then I have minus 4 at the end. So my k value is negative 4, and that's down 4. So I vertically stretch this by a factor of 3. Then I move left 5 and down 4, so that my endpoint is now at the point negative 5. I'm sorry, negative 5, negative 4. I just wrote that backwards. Okay, and our last one. G of x equals the positive square root of 1/2 times the quantity x minus 7. So this 1/2 is where our 1 over a is. So that means that our a value, but it's horizontal, is actually 2. So this is a horizontal stretch by 2. So it's going to get wider. And then x minus 7 actually gives me a positive h value of 7. So I'm going right 7. So the only thing that affects my endpoint is the right 7. So my endpoint is at 7, 0. Now that we've had some practice just identifying transformations, we are going to do the same thing, but then actually graph them. And if you need to graph the parent function to begin with, just to kind of look at, you can, and I might do that for the first few. So when we transform the parent function, we need to remember that the endpoint starts at 0, 0, and then we have these specific points, 1, 1, and 4, 2, okay? So if we remember those, we're always going to transform those points. The easiest way to do this is to start with your endpoint and then do everything from there as if your endpoint is still sitting at the origin. In letter A, we have g of x equals the positive square root of x plus 4, then plus 2. So I have x plus 4, which means my h value is negative 4, and I am moving left 4. My k value is positive 2, and that's up 2. So my endpoint is at the point negative 4, positive 2. So I'm going to draw my transformed graph, left 4, up 2, there's my endpoint. Now I'm going to draw my next 2 points that used to be at 1, 1 and 4, 2. I'm going to count 1, 1 and 4, 2 from this new endpoint. So over 1, up 1, and over 4, up 2. And there is my transformed graph. Let's look at B. I'm going to draw my original graph on B as well. I have 0, 0, 1, 1, 4, 2, something like that. In letter B, I have 3 on the outside. That's my A value, which is on the outside. So that's a vertical stretch by 3. And then I have minus 2 at the end. That would be my K value of negative 2. So that's down 2. So the only thing that affects my endpoint is the down 2. So my endpoint is at 0, negative 2. So let me plot that. Now, instead of counting over 1, up 1, I'm just going to put an X there, and over 4, up 2, because I'm vertically stretching by a factor of 3, those up movements need to be multiplied by 3. So instead of over 1, up 1, like that X is showing, I'm going to go over 1, up 3, and I'm going to put a dot there. Instead of over 4, up 2, I'm going to go over 4, up 6, because 2 times 3 is 6. That will bring me up to the 0.44. So this graph, as you can see, has gotten much taller, but also moved down 2 units. Okay, let's try letter C. G of x equals negative 3 times the positive square root of x minus 2 plus 3. So that negative 3 is my A value on the outside. Remember that the negative just represents a reflection. So that's a reflection over the x-axis. And then the 3 is a vertical stretch by 3. So imagine this. I did draw a picture of a reflection over the x up here. It was this red one we talked about. If I reflect over the x-axis, it just starts at 0, 0 still, but it's going down and to the right. And then if I vertically stretch that by a factor of 3, it's just going to be like letter B, that much stretch, but in the opposite direction. And then my h value is positive 2. So I'm going right 2. And my k value is positive 3. So that is up 3. So right 2, up 3. My endpoint is at the point 2, 3. So now pretending that that endpoint is the origin, our original graph would have been starting there and gone right 1, up 1, right 4, up 2. But we reflected that. So actually, that would go right 1, down 1, right 4, down 2. Okay. But not only did I reflect that, I vertically stretched it by a factor of 3. So instead of going right 1, down 1, I'm going to go right 1, down 3. Instead of going right 4, down 2, I'm going to go right 4, down 6. Let's see, 2, 4, 6. And my curve will be going down and to the right. Okay, we're going to do letter D, and we will do the last 2 in class. G of x equals the positive square root of 1/2 times x plus 3, then plus 1. So this 1/2, remember, it's on the inside, though that's a horizontal thing, but that's where 1 over a is. So 1 over a is 1 over 2. That means a is 2, so that's a horizontal stretch by 2. Then I have x plus 3, which actually means h is negative 3. That's left 3. And then I have plus 1 at the end, so my k value is 1, and that's up 1. So those last 2 things help me know my endpoint is at negative 3, positive 1. Okay, so the only thing I have left is my horizontal stretch by 2. So I'm going to do similar to what I did before. Before, I would just go right 1, up 1, and right 4, up 2. But now because I'm horizontally stretching by 2, instead of going right 1 and up 1, I'm going to go right 2 and up 1. And instead of going over 4 and up 2, I'm going to go over 2, 4, 6, 8, and up 2. So here are my actual points after horizontally stretching So as you can see, it elongates it horizontally. All right, guys, we're going to do the last two in class and have some practice together. Have a great day.